Imagine stepping off the edge of everything. Ahead of you floats a sphere of perfect darkness, swallowing the stars behind it. You feel no wind, no heat, just the certainty that once you cross that edge, there is no coming back. This is a black hole. It isn't a hole in the ordinary sense, and it's not a cosmic vacuum cleaner roaming the galaxy. It's a place where matter collapsed so completely that gravity overwhelms everything, even light. So what would truly happen if you fell in? The honest answer depends on which black hole you choose, and the journey is far stranger and far more beautiful than most people imagine. Let's take the plunge together. Let's start with a stellar mass black hole, formed when a giant star runs out of fuel and collapses under its own weight. It might pack several times the mass of our sun into a region smaller than a city. From a safe distance, it looks deceptively calm, almost peaceful. As you drift closer, you notice the starlight around the black hole, bending into rings. Gravity is so intense here that it warps the paths of light, wrapping images of the sky around the darkness like a funhouse mirror. This dark sphere has a name: the event horizon. It isn't a solid surface. It's simply the point of no return, the boundary where the escape speed finally exceeds the speed of light. Cross it, and the universe locks the door behind you. But long before you reach that boundary, something dangerous begins. Gravity doesn't pull on all of you equally. Your feet, a little closer to the center, feel a noticeably stronger tug than your head, and that difference grows with every passing moment. For a small black hole, this difference is brutal. The pull on your feet becomes so much stronger than on your head that you stretch. Scientists gave this grim effect a playful name: spaghettification. You'd be drawn out into a thin strand of atoms, torn apart long before you ever glimpsed the edge up close. For a black hole just a few times the sun's mass, the trip ends right here, quietly and violently in the dark. But what if we choose a different monster? At the heart of most galaxies lurks a supermassive black hole, millions or billions of times heavier than the sun. Counterintuitively, these giants are gentler to a falling traveler. The bigger the black hole, the more spread out its gravity is near the horizon. Around one of these titans, the stretching force is so mild that you could cross the event horizon without feeling a thing. So let's fall into a supermassive black hole instead. You point yourself toward the darkness, take a breath, and let go. Behind you, a friend watches from a safe, distant orbit, recording every second of your descent. What each of you sees will turn out to be wildly, impossibly different. From your friend's point of view, something eerie happens. As you approach the horizon, you seem to slow down. Your falling image drifts, hovers, and freezes just above the edge, never quite crossing it. This is time dilation. Near a black hole, the flow of time itself slows relative to the outside universe. To your friend, your clock ticks slower and slower, until it appears to stop entirely. Your image also reddens and dims. The light you reflect must climb out of a deepening gravity well, losing energy as it struggles upward. Slowly, you fade from view, a fading ember pinned to the dark. To your friend, you never actually fall in. You simply grow dimmer and redder, second by second, until you vanish from the recording entirely. But from your own point of view, none of that strange freezing is happening at all. You feel no slowing, no freezing. You fall smoothly, gaining speed, watching the black sphere swell to fill your vision. And then, without any fanfare, you cross the event horizon. Here's the astonishing part. You might not notice the crossing at all. There's no wall, no flash, no barrier of any kind. The point of no return is completely invisible to the one who passes through it. You'd only know from the sky, but the universe outside now looks profoundly strange. Light from the entire cosmos behind you crowds into a shrinking, brilliant circle high overhead. The stars distort and pile up around its rim, painting a warped, glittering portrait of everything you have left behind forever. And time takes on a chilling new meaning. Inside the horizon, the singularity at the center is no longer a place you could turn around and flee. It lies in your future, as unavoidable as tomorrow. No matter which way you fire your rockets, no matter how hard you struggle, every path leads inward. Down here, falling toward the center, is as certain as the passage of time itself. So what waits at the very center? Here, our best theories break down completely. Einstein's equations predict a singularity, a single point where matter is crushed to infinite density, and where space and time, as we know them, simply lose all meaning. But we don't truly know. To describe the singularity, we'd need a theory that unites gravity with quantum mechanics, and that theory doesn't yet exist. The core of a black hole is one of physics' deepest mysteries. Before you reach it, though, spaghettification finally returns to claim you. Even in a gentle, supermassive black hole, the tidal forces grow without limit as you plunge toward the center. Eventually, inevitably, the stretching wins. Your body is drawn into a thread, then torn atom by atom, then stretched beyond anything we have words for. Whatever you were becomes part of the black hole's mass, hidden forever behind the horizon. And yet, even utterly destroyed, a faint trace of you may remain. Black holes are not entirely permanent objects. They slowly leak a whisper of energy into space, a process first predicted by physicist Stephen Hawking, and now named Hawking radiation in his honor. Over unimaginable spans of time, far longer than the current age of the universe, a black hole can evaporate, shrinking and finally winking out. What becomes of the information that fell in remains fiercely debated. This puzzle, the black hole information paradox, sits at the frontier of physics. Does the universe truly forget everything that crossed the horizon? Or is that information somehow preserved? No one is certain yet. There's one more twist worth savoring before we go. You may have heard that falling in lets you watch the universe's entire future flash past. That isn't quite what happens. A diver reaches the center far too quickly. The real-time machine works differently. Instead of falling, hover just outside the horizon, engines blazing, then fly home. For you, only years would pass. For everyone you left behind, millennia. That's a real doorway into the future, and you could return to tell the story. So the truth about falling into a black hole isn't a single story. A small one shreds you before you arrive. A giant one welcomes you in quietly, then keeps you forever. Either way, you meet the same fate at the bottom of the deepest well in the entire cosmos, a place where the rules of space, time, and matter, and our understanding of reality itself, finally run out. And maybe that's the most humbling part. These objects are not science fiction. They are real, scattered across the sky, some feeding, some sleeping. Each one a sealed question written into the fabric of space. Every time we study them, we're peering straight at the edge of what physics can currently explain. A black hole doesn't just swallow light and matter. It swallows our certainty, too, and quietly dares us to keep asking anyway. If wonders like this make you want to understand the universe a little better, subscribe and stay curious with us. There's a whole cosmos of strange and beautiful questions waiting, and we're only just beginning to explore it.